Ma'am, if we start, let me continue with what we have discussed in our previous discussion. Okay, the agenda for today's session is we are going to continue with the concept of MongoDB. This is the agenda for today's session. We are going to continue with, we are going to start with MongoDB. So under MongoDB, we are going to discuss about this concept of indexing. In our yesterday's session, we have created databases, we have created collections, we have inserted documents into the collections. We perform the query activity, and update and delete and projection has been discussed in yesterday's session. We are going up with the concept of indexing, how to create index. So indexing helps us in retrieving information in a quick manner. We are going up with this concept of aggregation. How to make an aggregation, how to perform sum, average, minimum, maximum like operation. We are going to discuss about the concept of replication. How we can ensure high availability by means of replication. And we are going to discuss about the concept of sharding. That is how to add a additional data node, how to distribute the data in a horizontal scalable manner. And finally, we are going to discuss about the backup, how to create a backup of data in MongoDB. And we have another two concepts, some additional concepts, how to make a join in MongoDB. So for creating a join, we go with this advanced joining concept, how to make use of this join. And finally, we are going to end up with this how to handle multimedia objects using grid.fs. Okay, so these are all the things that are associated with MongoDB. Followed with, we are going to start our discussion on the scheduler OZ. What is Apache OZ? Okay, how to configure OZ and how to create a OZ script. So to specify workflow, script for specifying OZ workflow by which the task can be automated. So this is the agenda for, we have already discussed about this, how to configure the EMR cluster. Now we are going to specify how to run a script, how to run a Hive script, and how to get this input and output stored in S3. This is the agenda for today's session. Let me start with this indexing concept of MongoDB. Okay, MongoDB indexing. So what is index? Index is used to ensure the retrieval of data in a very fast manner. Okay, so it is used to retrieve the query in a very quick manner among these available documents. Okay, so without index, if you don't have an index in your table, so your document will look for all the information. Similar to that of a book index, it will restrict the access, number of documents that you need to access if you have created an index. Okay, so they are nothing but special data structures, and they have some value using which you will be taken directly to the area where you are looking for your query. So for creating an index here in MongoDB, we are making use of a method called as ensure index. This is the method that you need to apply on the field. To which field that you need to create index, you need to apply this. The command is database dot, let me make the collection name dot, let me create an index for the employee number. Therefore, what you need to do, ensure index, you want to specify the index key. Okay, let me make it the employee number instance, open the brace, employee number, you want to specify the index value, either as a positive value or as a negative value. Okay, so if you create one, employee number 1, the positive index will be created. That is, the index will be created in an ascending order. If you want the index to be created in a descending order, you need to make it as -1. So this is the way by which by creating an index either in an ascending or in a descending order. Once the index has been created, okay, automatically when you make a query, then based upon the index value, your query will be very fast. It is not mandatory that you need to create index on only one field. You can also create index on multiple fields also. In this case, if you want to create an index on two fields, then we create an index based upon this employee number. That is the first field that you are interested. Then the second field that you are interested, if you want to create an index based upon some salary, your query is going to be work with some salary, then salary colon, you are looking for creating an index in a descending order of salary. You are looking for a salary greater than 10,000, or so your query is going to frequently have salary greater than 10,000, 15,000, like if it is going to apply a condition on salary field, if you create an index on salary field as a secondary index, it will ensure a fast retrieval of your information. Okay, this is the way by which you need to create an index. Please make a note. There are several options associated, so which is beyond the scope of what it is. Now the next, we are going to discuss about how to apply this aggregate operation. Aggregate. How to apply, just to find out the sum, average, minimum, maximum operations on your data. Then we imagine you have a record with the employee number, employee name, and job and salary. So you are going to apply this activity on job. Okay, you have a job DBA, you have job engineer, you have job clerk. That we make you have the data containing the above set entry for the jobs. Now you are going to find out what is the sum of the job for a DBA. What is the average salary? What is the minimum salary? What is the maximum salary for the DBA? So this is the way by which you are going to apply these aggregate operations according to your requirement. The syntax is, so DB dot, you want to use this name of the collection, employee dot, you want to specify a keyword called aggregate. This is a method. Aggregate is a method using which you can able to find out the above set aggregation values. Okay, assume that you have the collection stored in the following form: employee number with the above set values. So how you can apply this aggregate activity to find for job average salary or sum of salary for job working as a DBA. Okay, our requirement is you want to find sum of all the salaries for jobs equal to DBA. This is your requirement. In your normal query, select what it will do. Job, sum of salary from the table name, group by job. So this is the normal SQL query that you will apply. So you will be group all the value based upon the job field. After that you apply salary on top of it. So the equivalent statement in Mongo is, so db dot employee dot aggregate. So you want to specify this condition here. Okay. So db dot employee dot aggregate, open and close brace. Okay. So here what you need to do. So you want to specify this group. Being you need to apply group. Here too you want to apply a group. Dollar group. So based upon which you are going to apply a group, colon, you want to specify the ID, the group ID, underscore ID colon. So being you are going to apply the group based upon this job, dollar job is the group field. So you are going to find out the total salary. Let me make it a total underscore salary. So for that what you need to do, you are going to apply this operation sum. Okay. So since you are going to apply this operation sum on this job field, okay, you are going to find out the total salary. Please make a note. You are going to make a group by job fill. For that job fill, you are going to find out the total salary. The total salary, for the total salary, you need to apply this dollar sum. Then, based upon which you are going to sum the salary. So you need to specify the salary fill, dollar salary fill, not one. Okay, dollar salary fill. You close this, and you need to open. You need to close 3 curly braces. Okay. So this one, and for this curly brace, second brace, you want to close. Since you are having multiple fields, you need to enclose within this square brace. And this being it is a method, you want to enclose this method using this brace. So this is the way by which you apply this group on this job fill. Here we are applying group by job fill by using this statement group where ID is job. You are going to apply this sum on the salary field. Here this is the dollar sum on the dollar field, and it will display. So sum of salary here we can make it display as the total salary. Select total underscore salary. So the sum of salary. This is a column alias. Total salary is column alias. Similarly, you can have a alias field. So what happened here in this case? It will display the salary total salary based upon this job. This is the way you can apply this condition here. You can replace this sum by average, minimum, maximum, any parameter. That's all. Remaining things are same. Okay, so if you want to find out the maximum salary, here you want to apply instead of sum maximum on the salary field. That's all. Okay. So here in this case you want to find the maximum salary. The alias name should be maximum salary. That's all. Similarly, if you want to find the minimum salary, dollar minimum. If you want to find out the average salary, dollar average. So these are all the ways by which you can create a group by specifying the field, and you can apply this function, aggregate function, once again on a field, and this is the alias class that need to be displayed. And the method that you are using is aggregate method. This is your table, this is your database. Okay. By the way, you can apply aggregate operation, the needle aggregate operation on top of it. Here being it is a array, you need to enclose using this square brace for this. Being it is a method, you need to enclose using this bracket for a method. Okay. So if you leave anything, it may result in an error. This is the way by which you can apply this aggregate operation. So next thing, replication. What is replica? To ensure high availability, so in our Hadoop, to ensure high availability, we will replicate our block. Minimum 3 replicas for each and every block. Okay, we have 3 replicas recommended. Similarly, here too we can store data across multiple servers. Okay, so to ensure high availability of your data, MongoDB uses a concept called as replication. Okay, to have multiple copies of your data set. So here, for this MongoDB uses a concept called as a replica set. It uses the concept of replica set. So it is nothing but you will be having a group of instance MongoDB servers. To have this group of servers, this server will contain the same data. For example, the server contain employee data. A group of servers. Okay, contain, if we have 2 replica, you have both the server contain the same thing. So here if you want, imagine that the server can able to hold 2 TB of data. Therefore you have 2 server with 2 replica. If you want to add additional 1 TB, what you need to do? You want to go to add additional server. Okay, 2 servers. with the employee same data with additional data 1 TB, 1 TB will be stored. Here, this is called as replica set. Okay, it is a group of MongoDB servers having the same replica. So here, if you want to add additional thing, you need to go for adding additional servers. This is called as sharding. Similar to you have one data node, and if your load increases, you will add additional data node. Okay. Similarly, here this data node is a group. This data node is a group. This group is a replica set, and adding an additional node to accommodate more data is called as sharding. That is the difference between a replication and sharding here. Sharding is nothing but horizontal scaling. Horizontal scaling has been termed as scaling. Replication set is nothing but, okay. So, to having a replica set. Here too we have a default 3 replica set. Therefore, each and every replica set will contain a minimum of 3 Mongo servers, Mongo machines in one particular replica set. Okay, one node is designated as the primary node. Minimum you need to have 3 nodes. One node is designated as the primary node. Remaining nodes are secondary nodes. Here, yeah, read and write, whatever thing that you are going to perform. If a user wants to perform a read on data, or if the user wants to write on data, he will do the activity on this primary data node only. The primary data node will perform this replication. For example, if you use to store the employee table, so the employee table will be given on the primary. The employee table, what it will do, we have multiple secondary nodes. It will make a copy of this employee on this secondary nodes. Okay, this is the way by which you can create. These are all this group of secondary nodes. We call this as a replica set. Okay, this is the way by which you can create a replica. So this is I am letting you know the concept and how to create a replica set and how to add your instance into a replica set. Step 1, creating a replica set. Okay, so you need to practice this by your own. These are all coming under L3 administration commands. How to create a replica set. Assume that this is your replica set RS0 and this is your RS1, the two servers. The command is MongoDB. You want to open a port -port. You want to specify the default port number. So this is the interview question. This is the default port under which MongoDB will be listening. --, database path. Since you have installed a MongoDB in the default location C drive, under data DB you want to specify this path, and -, you want to specify the replica set RS0. Therefore, the instance will be created with this instance value as RS0. Okay, this instance will start listening on the port number 27017. So here you can connect with this in your Mongo shell. Simply start your Mongo. It will connect to this Mongo shell. What you need to do here to find the status, simply replica set dot conf. This is the command which is used to get the configuration information. Okay, to check the configuration information. To check the status, rs.status. This is the way by which you can create a replica set and you can add the replica set to the instance. Okay. These are all things which is coming under admin perspective. So I need to make aware of what is replication, what is sharding, then how to create a replica set. That's all. Now we are going to discuss about how to create a backup of your data. So for creating a backup, Mongo uses a command called as MongoDB. So MongoDB is command which is used to create a backup. Here, you connect to this Mongo daemon. So assume that you installed Mongo in your C drive. So under C drive, you will be having a bin folder. Okay. So when you install the Mongo on a particular location, you have. Hello? Is it audible now? Is it okay? Yes. So move to the location. Okay, where you have installed this Mongo. And here in this location, simply type Mongo tab. It will take you to the backup utility. So once you type this Mongo tab, so it will connect to this particular server. Since we are configuring only a single node, in our single node instance, we configure this Mongo on this single node. It connect to this server. Okay, so it connect to this port number, the default port number 27017, and it will start backing up all the data associated with the server, and it will be stored under a location /bin. It will create a folder by name dump. So here this slash, not this slash. Okay, under the bin, it will create a folder by name dump, and the dump folder contains all the data associated with the particular Mongo server. You can find the data. Okay, here it will take the data, it will take the metadata, it will take everything, and it will store under the dump folder. Okay, so the directory will by default it will be created. Once you install Mongo, it will be by default it will be created. Please make a note. So this command need to be executed with this bin folder of the MongoDB installed location Mongo dump. Automatically the data associated with the server will be copied and it will be stored under the following folder. Again, dump under bin. So all others can hear. Ma'am, you alone, you want to restart. All others can able to hear. Ma'am, all others can hear me. Please restart. Am I audible to all? Deepraj, Gold, sir. Am I audible? Yes. Ma'am, you need to restart, ma'am. Okay, so this is the way by which you can take a dump. Then how to restore the dump. So you have multiple options with your Mongo dump. If you are looking for taking only a specific database, imagine you have three databases, through one database, sample is another database. Okay, if you issue this command, it will back up all the databases, both the Thiru database and sample database. So if you want to back up only the files associated with the Thiru database, the command is you want to specify the database, Mongo dump, along with this option. You want to specify the database path, being you store the data under the following location: C drive, under data, under DB, you want to specify. So you want to specify the location where you need to store slash data slash backup. Okay, before that you should use database name so that you will be connected to the database and all the associated things will be listed. You want only this Thiru contain multiple tables. It will contain employee table, it contain department table. You want to copy only the employee table instance. The command is MongoDB. You want to specify the collection, hyphen collection, name of the collection employee, belonging to the database. The database is true. Okay, this is your database name. This is your collection name. That is your table name. Okay, all the data associated with the employee table will be now dumped. This is the way by which you can make use of the MongoDB to make a copy. So the copied location will be under the following path. You can specify the path under data, under backup, it can be copied. So if you don't specify any path, then this is the default path. Under bin, a dump folder will be created under which it will be specified. Okay, so these are all the ways of making a backup of all database or a particular database or only a collection associated with the database. To restore, imagine you have a data stored in this location. Okay, you have data stored in this location. To restore, simply type Mongo restore. The backup file, where you have backup files. Assume that you have a backup file in this system. Move to the location under C drive, under this Mongo, where you have installed this MongoDB. Under MongoDB, you have a bin folder. Under a bin folder, you have a dump. Okay, move to the location under this dump and simply type Mongo restore instance. The dump file that is associated will be restored. So this is the way by which, by using a Mongo dump and Mongo restore, you can able to copy a backup of the associated thing and you can able to recall the backup. So these are all the things associated with creating a backup. Now we are going to discuss about how to create a join, how to apply joins here. You have these two tables, employee table and the department table. How to associate this content of employee table and department table and display as a same table, employee department table. So here for this, you go for a concept called as relationship. In Mongo, in order to invoke the joining of these two documents, assume this is a collection 1, employee collection and the department collection. In order to join the documents, we have multiple documents. Here too we have multiple documents. In order to join the documents associated with this collection, we go for a concept called as relationship. Okay, there are two types of relationships here. One is reference relationship, another one is embedded relationship. We have two ways by which you can connect. One is embedded relationship and second is reference relationship. What is the difference between these two relationships? Okay, so assuming that we have two, this employee and the department information. You have this employee contains the following ID, unique ID. You know the object ID. We have discussed about this object ID. That we assume this ID is 511, etc., etc. And you have this employee number 1, and you have this employee name Ram. Okay. Then you have this employee job DB. So these are all the entries associated with employee. Let we have a unique ID for department. The department object ID is, let me start with 610, etc., etc. And you have a department number. Department number is 10. Okay, you have a department name. Department name is EDP. Let we assume here the city. Okay, the city of the department. Let we make it as Chennai. So here you have a department number. Apart from employee number, you have a department number associated. So these are all the two collections. One employee collection and another department collection with the opposite IDs. You have object ID starting with 511 for the employee, object ID starting with 610 for department. How you can represent this here? How this thing can be represented here? Either by using this two way, either by using a embedded or by using a reference. Okay, these are all the two ways by which you can make use of it. First, let me discuss about embedded. In embedded, what you need to do, you want to include this information within this the primary employee table itself. So, in embedded approach, we will embed the department document inside the employee document. That's all. Okay, in this we need to add additional thing, the department, the entry for department, colon, and you want to specify all the things within open and close brace. Okay, all the department number, department name, city need to be enclosed within this. That is the way of using this embedded relationship. So in case of reference, we no need to embed each and everything. What we need to do, you want to simply embed the ID only. Okay, let me create a reference here. Let me create a reference. Here you have this ID, you have this object ID. So your ID starts with let me make it 511, etc. And under which you have the following information: employee number 1, comma, employee name is Ram, comma, and then you have a job is DBA. So here what you need to do, if you want to add this department, you specify this department colon followed with, you can specify the object ID. Okay, in this I will make a note. Here department, you want to specify colon, in this object ID of both things, the object ID of department, assume that it is 610, etc. and you want to specify the object ID of the original table, that is the employee table, which is 511. So this is the way by which what are all the separate documents that you want to embed, you can embed within this. Okay, so here this particular document will have the entry for the object ID 610 and object ID 511. The object ID 511 is assumed to be employee, the object ID 611 is assumed to be department. This is the way by using this reference string. You don't need to embed all the things. In your embed document, you want to embed all the data with the associated fields. Whereas here you want to refer only the object ID. Being your object ID is unique for the document, your object ID be that particular document alone will be embedded here. This is the way by making use of the concept of embedded relationship or by reference relationship, you can able to make a join across multiple collections by in MongoDB. Okay. If you want to include another thing, so for example, if a person is having a, let me make another example. If a person is working with two departments, he belongs to both the accounts department, sales department, also he belongs to purchase department, both departments. There is a possibility A consultant may work with two departments. In this case, what you need to do? Each and every department will have a unique ID. Okay, you want to refer that ID also. Assume the ID for the first ID is 610, then the second object ID, if it is 700, then you want to specify the object ID. If the person need to be referred with multiple documents and all the associated documents object ID need to be referred here. This is the way by which applying this the relationship you are able to join the multiple things here. Okay, we have a lot of things to be discussed. We have multiple things. I am letting you know an overview. That's all. Now, how to store a multimedia objects. These are all the usual interview questions that will be put across. Grid efforts. We are going to discuss about a file system called a grid file system, which is used for storing multimedia objects such as your image files, your video files, your audio files. Okay, since your big data need to support this unstructured data which is coming under image, video and audio, here MongoDB uses the concept of a grid file system which is used to store the portion. Okay, so here for storing this particular high volume, this object files like image, video and audio, so it uses two collections. These informations will be stored under two collections. That is, two collections are nothing but it stores information under two tables. One is FS file is one table, another table is FS chunks is another table. These are all the two things. So here this FS file contains the metadata information about the file that you are going to store. Example, you are going to store rom.jpg is a file. So this file may contain two things. One, the file's original data and the metadata of the file. What is the size of the file? Who is the owner of the file? Like what are all the access permissions? Those metadata has been stored in FS file, and the file being it is of huge size, it is splitted into small chunks, and those chunks will be managed under this file. Okay, each chunk is identified by a unique object ID. Each chunk will be identified by unique object ID. So it is this fs files. It will contain the links of all the associated chunks. For example, assume that the chunk is having object ID 1, 2, and 3. Those information will be present in the FS files. The rom.jpg contains the chunk 1, 2, and 3. Those chunks will be stored, 1, 2, and 3 will be stored in a separate file, fs.chunks, and metadata will be stored on this file. Let me now discuss how to add a file to this grid system. Okay, so the command to add a file is mongo connect to mongo files.exe. Then you want to specify the target directory as grid file, and you want to use this command put for specifying this rom.jpg. This is the file that you want. Okay, so here this is your database name. So in this, let me make it the database name as Thiru. So under Thiru database, the file rom.j will be put under the Thiru database. Okay. So under this, it will contain two information. Okay. One is FS file. It contains the metadata information about this rom.j, but the original data will be stored here. So how to look into this? How to query? To query db.filesystem.files.find. So it will look into this fs.files associated, and it will list all the associated things. The file name is rom.jpg. That it is divided into this number of chunks. It is uploaded on the following day. The total size of the file, etc., etc. All those informations will be found here. So along with this object ID, this command will return the object ID of the corresponding file. If you want to look into the data, the command is db.fs.chunks.find Here in this open parameter, you want to specify the object ID, files underscore ID. You want to specify this object ID that it's returned. So once you specify this object ID of the file as an argument and all the associated data, okay, will be returned. Example, in this case, it is assumed that run.jpj has been divided into 3 chunks instance. All the 3 chunks will be listed here. This is the way by which, by making use of this fs files and fs chunks, you can able to retrieve both the metadata as well as the data from the file. So with this, let me come to conclusion of the discussion of MongoDB. Okay, let me move on to how to add a
doubt, sir.
Yes, sir. Yes, sir.
இல்ல சார், நம்ம வந்து இப்போ செமி ஸ்ட்ரக்சர்டு அன்ஸ்ட்ரக்சர்ட் டேட்டா பண்ணும்போது மிஸ்ஸிங் வேல்யூஸ்லாம் இருக்கும்ல சார், அதாவது நல் வேல்யூஸ்லாம் இருக்கும்ல, அதை வந்து இந்த MongoDB எலிமினேட் பண்ண முடியுமா, இல்ல பிக் மாதிரி இதுல ஒர்க் பண்ண முடியுமா சார் நம்ம இந்த டேட்டாஸ் வச்சு?
Okay, so now the cluster is in the running state. You need to add this step. Click on add step. Then you choose this file as Hive program. Then you name of the file as, you choose a file name, any file, whatever may be. So the script location, the input location. You want to copy the input location. US West 2. Okay, being you are correctly connected with Virginia, it is US East 2. I think so. The Virginia is US East. Okay. So next, what you need to do? You want to copy the script location. Here is your script. Okay, here is your script. The output location that you can select. This is your script location. S3 US East. This is your script file. Copy the script file. Move to the location. Simply paste. You are in US East. Therefore, replace with US East. Okay, now you have this S3 location, script location, and you have this input log location. You want to specify the output. Click on the output. You just specify EMR2 as your output. Okay, select. All the output will be recorded here. You want to specify an argument here. You want to specify one argument, and this argument, this is the argument that you want to specify here. I-config, I support reserved keywords need to be false. So it's because the log file contains several reserved keywords. Okay, so you want to specify everything. So if everything is perfect, your cluster will be launched. If not, you are instructed to terminate the cluster. So these are all the ways by which you can have your script file, you can have your input file, and you can store the processed output in the S3. So let's say we get a folder here. Okay, add. So one of the following, the bucket name must contain only lower case. Okay, so here we have 2 S3, that is the reason. We have wrongly copied. Yes, invalid bucket. S3. Now you can find the steps have been added. The cluster it's in the running state. Okay, so if everything is perfect, it took a minimum of 5 minutes to update this script, and everything is perfect. You can get a output in the above specified folder. Oh, sorry, we have wrongly specified. It should be US-East-1. Okay. We launch a cluster here itself. My cluster, it is from 2 M3 launch. Let me try to launch another one. Easy to keep back. So shit. Okay, actually the instance that we launch may fail. Also because we have wrongly given this bucket URL. Let me wait and check, and only thing that you want to specify is the location, correct location of your S3 bucket. There being Oregon State, it is US West 2A, then Virginia, US East 1. I have wrongly mentioned that US East -2. You can find this is US-East-1. Instead of that, I had mentioned that US-East-2. So it may be a problem. Let me check and wait. Okay, the cluster is now ready. Still it is in the waiting state. Each and every step has been added here. You can check with this S3 whether we have created any logs here. So the logs created by the cluster will be recorded here under EMR. You can find a OS request and OS request folder. So here it is successful. Okay, now we can find under EMR we have a OS request, and this is the file. You just download the file. You click on this is the file where we have the data. You just download the file. Okay, click on download. Now the file is 000. You can store the file in a desktop and you can open a file. It will be open using a Microsoft Notepad. Okay, now you can find it contains Android number of requests coming from Android is 851. Number of Linux machine is 813. Number of Mac OS is 852. Okay, other Windows OS is 883, and Internet operating system is. And these are all the information associated with this particular input log. Okay, so if the cluster is success, you will receive this input. This is the way by which you can create a EMR cluster, under which what you need to do, you need to specify two things. One, the input for, during the creation of cluster, you no need to configure anything. So the difference between going up with the Hadoop as a service and configuring a Hadoop using EC2 as a service here is, so here if you are using EC2, you want to do all the steps one by one. Okay. Here if we are going to make use of this EMR is what we did. We did only one thing. One, we specify how many number of masters and how many number of slaves that you need. Similarly, we specified two. That's all. Then we have specified only the configuration. What is the default? We make use of the default configuration of M3 large instance. And apart from that, in this step, we have specified three things. One, we have created a S3 folder for our output. Similarly, we need to create a S3 folder for our input data, as well as for our script. We need to have these three folders: the input folder, the folder which containing the script, and a folder where the processed output need to be specified. That alone that you need to give. In the step, you need to specify the above three things, and everything is perfect. The data will be processed according to the logic written in the script, and you can receive the output, and the output will be stored on the following file. You can download the file and you can able to view the output. This is the way by which, by making use of your Hadoop as a service in your Amazon as a EMR, you can able to run a sample script. Here we make use of a script which is given by Hadoop itself, which is given by Amazon cloud itself. If you have your own script, what you need to do, you want to upload the script into the S3 folder, and you want to give the access permission for the script to be public. And similarly, you want to upload the data that is associated with you into the S3 folder, and you apply the script on top of the data to produce the output. Yes, this is the way by which you can configure the EMR Hadoop cluster. Once you configure this cluster, don't forget to terminate the cluster. Also, because it may result in, if you run this cluster every hour, you need to pay minimum of rupees 100 to 150 rupees per hour. Therefore, it is a best practice to click on the cluster and to terminate the cluster. Once the activity has been over, the cluster needs to be terminated. You can make a check with this EC2 whether the terminated cluster is terminating or not. Else you will be running this M3 logs. For every 1 hour you need to pay not less than rupees 100, up to 100. So with this, our discussion on this second part EMR is over. So let me have our discussion on the third part, Apache Uzi. And how to write your UDF, Hive and Peak UDF in the coming session. Okay, it is now start terminating. So for having an impact, it took around 3 to 4 minutes.